Hey kids, Smath here. Got another gas law problem for you. This one is a gas stoichiometry problem. Now, we did stoichiometry earlier in the year, but we didn't do it with gas laws because we didn't know what to do when we had conditions that were different than standard STP. So now we know what to do with that. We can use the ideal gas law to correct for that. What this problem has, it says we've got what volume of NH3 is produced at 72 degrees Celsius, 3.55 ATMs, when 4 grams of CaOH2 reacts with excess NH4Cl. So we don't have a chemical reaction. We got to do stoichiometry. So we're going to have to write one. I think we can do that because they give us what volume of NH3. So that kind of tells me NH3 is going to be over here on the product side when 4 grams of CaOH2 reacts with excess NH4Cl. Now I've got to figure out what's my next reactant going to be. Well, it looks like a double replacement reaction, and my calcium's going to combine with that chlorine, and that's going to make CaCl2. And then if you notice, we've got some OHs and Hs here. That's going to make a little bit of water. Now that's a pretty hard reaction to write, so no problem if you couldn't get that. The reaction's probably going to be given to you most of the time, but it was a good way for us to kind of review that reaction writing. And we also have to look at this and balance it now, because this isn't quite a balanced reaction. I've got Cl2 over here and only Cl there. So I'm going to put a 2 in front of my NH4 and a 2 in front of my NH3 and a 2 in front of my water. Now that went really fast. I apologize for that. But if you take a few minutes and look at that, I think you'd come to those same conclusions. Now let's get on to the stoichiometry of it. I've got 4 grams of this stuff, and this is running in excess. So we don't need to worry about that. We have 4 grams of CaOH2. And if I look on my periodic table, I get the molar mass of that. It just happens to be 100 grams per mole of CaOH2. I got that from 40 for calcium plus a whole bunch. Wait a sec, that's not right. That's going to be 40 plus 17, and 17 is 30. That's going to be 74. This is going to slow us down quite a bit now, kids. 40 plus, all right, we're okay. And then let's finish this out, and we'll just finish the whole calculation. Well, how much NH3 am I getting? I'm getting 2 moles of NH3 for every 1 mole. That's the stoichiometry of this, CaOH2. And that's going to give me my moles of ammonia that I need that I can put into an ideal gas law. Now, I apologize for making a mistake here, but that's okay. We all make them, kids. 4 times 2 is going to be 8. Divide that by 74. I've got 0.11 moles of NH3. Now, that's got to go into the ideal gas law, PV equals nRT. What's my pressure? 3.55 atmospheres. My volume? What volume? That's what we want to know. And how many moles? We just calculated that, 0.11 moles. Which R would we like to use? Well, our pressure is going to be in atmospheres over here. So like usual, we're going to plug in 0.082 liter atmospheres per mole Kelvin. Speaking of kelvins, we have 72 Celsius, 273. That gives me a 5, a 4, and a 3. 345 kelvins. That's pretty warm, not going to lie. So if we punch this in, throw the 355 over into the bottom here, that'll isolate the volume. We get 0.11 times 0.082 times 345 divided by 3.55. The volume of this is going to be in liters, is 0.88, 0.876, 0.88 liters, 880 mils-ish. Circle in your answer. So here we took an equation, ran the stoichiometry of it, then all we did was take the moles, plug that into the ideal gas law, and we were able to find out what volume this gas was going to occupy. That's a pretty straightforward problem using the ideal gas law and reaction stoichiometry. I'm Smath. I hope this video helps you.